Hi, this is Troy Tacey from Fordham University, and this is the 7th video in my series on understanding the current coronavirus outbreak around the world and in the US. So if you haven't seen the first 6 videos, there's background material. They may be helpful for understanding some of this material. I'm trying to make them all stand alone, but some of the material from the earlier videos may help you out. So if you're interested, you can go to my Google Sites webpage. I've got links to all the YouTube videos as well as some other information that I've written on COVID-19. So again, my name is Troy Tacey. Google me and you should be able to find the Google Sites page pretty easily. So this is part 7, and we're going to talk a little bit more about the reproduction number R, and we're also going to use it to talk a bit about the epidemic peak and understanding what happens after we hit the peak of the epidemic. So let's quickly review what we mean by the reproduction number. So remember, the reproduction number is it's the number of average infections that each infected person in the population creates. And we can measure R by taking the product of the contact rate C, the transmission rate T, the duration of the infection D, and the fraction of susceptible people in the population. Now, if this reproduction number is bigger than 1, then our epidemic is going to grow. It's as though each infection creates more than one additional infection in the population, so the number of infections gets larger. On the other hand, if R is less than 1, then each person in the population creates less than one additional infection on average. So when that person recovers, then we have fewer infections left in the population. So R is bigger than 1, the epidemic grows. If R is less than 1, the epidemic shrinks. Now, as the epidemic grows, one thing to keep in mind is it grows by converting susceptible people to infected people. So as the epidemic gets bigger, the fraction of susceptible people has to get smaller. So let's assume for a moment that S is near 1 at the beginning of the epidemic. Then we can measure the initial reproduction number, or R0, or sometimes called R0, as just being the product of the contacts, the transmission rate, and the duration of the infection. So then the epidemic takes off, S starts getting smaller and smaller, and eventually, as S gets smaller, that reproduction number shrinks to be less than 1. And specifically, in order for that to hit this point where R is less than 1, we have to have S less than 1 over R0. So for example, if R0 is equal to 2, then we need to get the number of susceptible people in the population to be less than 1/2 in order to hit that epidemic peak. So let's go back and look at one of the examples that we did earlier from the Excel spreadsheet that I used to motivate some of the modeling that we did earlier in the class. The peak of the epidemic, so the red line, this is the number of current infections in the population, and this blue curve is the fraction of susceptible people in the population. And what we can see is the epidemic runs up, we hit this peak, and right where we hit this peak, if we extend this line up, this point right here is where we have 50% of the people in the population susceptible. So we hit that point of 50% of the people being susceptible. That tips our reproduction number to be less than 1. The reproduction number is less than 1, and the epidemic starts to fall away. Okay? Now note though, when it falls away, that doesn't mean that everything is over. We still have a significant number of people infected, and we still have a significant number of new infections happening here, right? So we hit the peak here, but the number of the fraction of susceptible people in the population is still falling, right? So we go from 50% down to about 20%. So that means that between the peak and when the epidemic finally disappears, we have about 30% of this population, for this particular example, infected. Right? So again, just to restate this, at the peak we have 50% infected or recovered. This tips us to having R less than 1, but after the peak we're still going to have a significant number of new infections. Right? And for this example, we end up with about 80% of the population infected overall in the epidemic. I think the coronavirus outbreak will certainly be less than that, everyone hopes. But the point of this is that if we have 80% of the population infected, 3/8 of those infections happen after the peak of the epidemic. So the 80% and the 3/8 and the 50%, all that stuff is specific to this particular example. But the thing that is more general than that is that we will still end up with a very, very large number of new infections after we hit the peak. So just because we hit peak infections doesn't mean that the epidemic is over. And because of this, one of the things that I'm sure we'll be talking about in the coming weeks or months as we reach the peak or pass over the peak is that we can't just automatically loosen the social distancing mandates and requirements that we've put in place once we hit this peak. So recall with social distancing, what we're doing is lowering the contact rate C. And by lowering C, again, we're making that reproduction number smaller so that we can tip it to be less than 1 with a smaller fraction of the population becoming infected. So once we loosen social distancing, we push that contact rate C back up to its original level. And if we do it too soon, then we could push the population back to a state where the reproduction number is bigger than 1, and then we start running up another curve, and we don't continue falling down the back side of that curve, right? So for instance, we hit the peak, we move down, if we loosen social distancing, we might see this red line start to increase again if we push that reproduction number to be a number bigger than 1 again. So how do we know if we're close to the peak? So what I did here is I just focused in on the one curve that we had earlier. And again, this is sort of the typical picture that you have for an SIR style model of infectious disease. So it kind of starts out slow, it accelerates, we get some really big increases, and then we hit this point where we almost have close to a linear fit on this curve right here, and then it sort of tips over again, and just before we hit the peak, this curve starts to increase at a decreasing rate, right? So we have increase at an increasing rate, something that looks relatively linear, then we have an increase but at a decreasing rate, right? So what happens is just before you hit the peak of this epidemic, the infection curve flattens out, and we get this inflection point where it starts increasing at a decreasing rate. And that happens usually just before we hit the peak of the infections. So we might be actually close to seeing that type of pattern in Italy right now. So this is the current data from the worldometers.info website. And this is the total cases of coronavirus in Italy. Okay. So again, if we look at these on the log scale, we talked earlier about how the curve has flattened out, which tells us that the epidemic is decelerating. Excuse me, the growth rate is decreasing. And then if we look at the number of active cases, we've got a picture that kind of looks like the Excel spreadsheet picture that I just had a minute ago, right? So we get this sort of slow takeoff, we get this fast acceleration, we've got this relatively linear part in here, and then it looks over the last week or so that this curve is, while it's still increasing, it's increasing at a decreasing rate. So this might tell us that we're getting somewhere around the peak in Italy right now, because effectively, if we go back to what I had earlier, it kind of looks like we're somewhere perhaps in this range in here for Italy, perhaps just after hitting the inflection point somewhere in here. So Italy may be getting relatively close to hitting the peak. Of course, as I've tried to emphasize in this video, that doesn't mean that the epidemic is over. They've still got to come all the way down this other side of the curve, and there's going to be lots of new infections on this side of the epidemic as well. Okay, so this was a short video. Hope it was informative for folks, give you something to look at in the data over the coming weeks. What I'm going to do next is just keep providing updates as I see something interesting in the data. I'll do another short video, and I will point out whatever interesting features I happen to see. I hope everyone stays well. Take care.